So this video is for integrated 3. It's a chapter 9 D-Day number 1. All of this would be on a no calculator test. So on number 1, when they're asking us to convert to 150 degrees to radians, there's 2 ways to go about doing this. One way is to think about it on the unit circle. I'll talk about that in a second. Another way is that you can take 150 degrees, times it by the ratio. And the ratio we're going to be thinking about is that we know that pi is equal to 180 degrees. So I can either go pi over 180 or 180 over pi. Since I want to get rid of my degrees, I want my degrees on bottom and my pi on top, so that my degree symbols cancel out. So I get 150 pi over 180. I can simplify that. First off, I can get rid of the 10s, the 10 from top and bottom, and get 15 pi over 18. But I can divide both of them by 3, and I get 5 pi 6. Now, if we look at the unit circle below, going from here all the way over to here would be 180 degrees. Now, remember, this is 30 degrees, 45 degrees, 60 degrees. So that means here, if I'm 30 short, I'm going to be at 150. And that is 5 pi 6 on the unit circle. Okay, on number 2, we're converting the other way. So we want to convert 4 pi thirds. So again, we can look at a unit circle, but I can take 4 pi thirds, times it again by either pi over 180 or 180 over pi. This time I want the pi on bottom, so my pi's cancel out. So my 180 degrees will be on top. So the pi and the pi cancels. I end up, let me simplify a little bit more. 3 goes into 180 60 times. So I'm going to get 240 degrees as my answer. Now, if I think about where 4 pi thirds is, 4 pi thirds is here. This is going to be at 180 degrees. This is 30 more. This is 45 more, this is 60 more. So if I add 60 onto 180, I do get 240. Okay, on 3, A. So this is negative, so we're going this way, and we're going negative 7 pi 6. Going to here to pi, that would be negative 6 pi 6. So I'm going to end up right here. That's where I'm going to be. And then the coordinates of that point. And if you want to make a triangle, you can. I'm not going to make it mandatory for you to. I do want the coordinates, however. So it would go to the center like that. Now, when I'm doing this point is going to be long, comma, short. So this is negative x, positive y. So negative root 3 halves, positive 1 half. So negative root 3 halves, positive 1 half. And sine is your y. So your answer is 1 half. Now I'm looking for 7 pi fourths. So 7 pi fourths, when I'm going all the way around to here, would be 2 pi or 8 pi fourths. So I'm 1/4 short, so I'm going to be right there. And so when I draw my triangle, oops, helps if I hold shift. When I draw my triangle, this is the one where this is actually isosceles right triangle. My x and my y are the same. So this is going to be positive root 2 halves, comma, negative root 2 halves. Now, I always say S doesn't go with S and C doesn't go with C. So really, I'm going to take the reciprocal of the cosine here. Let me just do this. Let me find my cosine. So cosine of 7 pi fourths, cosine is your x. So my x is a positive root 2 halves. So we're going to flip that. It's going to be the reciprocal of that. So I'm going to write this in purple. So I'm really going to take 2 over root 2. I'm going to rationalize top and bottom by multiplying by root 2. And I end up with 2 root 2. Let me scoot this over closer. So I end up with 2 root 2 over 2, which cleans up to just plain old root 2. On letter C, 80 pi thirds. Now, instead of circling and circling and circling, I'm going to see how many times does 3 go into 80? Well, it goes into this 6 times. Oops, not 6 times, sorry. Twice, which is a 6. So that's going to be 2, bring down my 0. It goes in, 3 goes into 26 times, which is 18, and I have a remainder of 2. So this is going to be 26 and 2/3. So when I keep going around and around and around a unit circle, every time I land here, this is going to be an even pi. And every time I land here, this is going to be an odd pi. So I can keep going around and around and around and around as many times as I need to get to 80 pi. But as I go around, remember, I'm going around this direction. As I keep going around, I'm going to end up here. And then I need to go 2 pi thirds more. So 2 pi thirds more is going to put me right there. And so this is going to be, if I'm looking at this triangle, the coordinates are going to be short comma long. So it's going to be a -1/2 comma positive root 3 halves. I want cotangent. Cotangent is x over y. So I'm going to have a -1/2 over a root 3 halves. We've talked about this before. That's going to end up being a -1/2 times the reciprocal, which is 2 over root 3. My 2's are going to cancel out. I'm going to get -1 over root 3, which I'm going to multiply top and bottom by root 3. And I get a -root 3 over 3. That is your answer. Okay, again, I multiply this by root 3. I'm just make this a little bigger. This by root 3 and this by root 3. Okay, so for these, I'm going to be trying to find 2 angles. So my cosine are my x's. So if I want a negative cosine, I'm going to be in quadrants 2 or 3. That's where I am. And my cosine is a root 2 halves here and here. So that's going to be at 3 pi fourths and 5 pi fourths. Those are my 2 answers. The next one's a cos. I can't remember. C doesn't go with C, so this is going to be sine inverse. And the reciprocal of a -2 is a -1/2. So I want to know where my sine is a -1/2. And sine is negative in quadrants 3 and 4. So that's where I am. And I need to pay attention to, do I want long comma short or short comma long? So this is short, this 1/2, and that's my y. So I'm going to want long comma short. So I'm going to be here. Whoops, make it a. I'm going to be here and here. Those are 6. So this is going to be 7 pi 6 and 11 pi 6. Tangent 0. I guess I lost my here. So tangent 0, let me just add one on. So tangent is y over x. So if I want to have this be 0, that means my y has to be the 0. My numerator has to be 0. And so I want my y0 here at 0 and at pi. Those are my two answers. On this one, we're going to graph the sine graph. My amplitude is 3 because of this. My vertical shift is going to be up 1 because of that one. My period is going to be determined by this 2 here in front of my y. So your period is normally 2 pi. That 2 says we have 2 complete cycles in 2 pi distance, which means if I take 2 pi and divide it into 2 equal pieces, the periods are going to be pi. And then my phase shift is going to be dealing with this x plus pi thirds. What makes that 0? And what makes that 0 is going to be a negative pi thirds. So in this case, I'm going to be starting at negative pi thirds. I'm going to be going pi away. And so I need to figure out where that is going to be. Now that is really going to be 3 pi thirds. So I'm going to get 2 pi thirds. So for this, let me sketch this. And we have to be careful because sometimes we don't end up with our y-axis being one of our marks. So let me just start like this. Okay, I know I'm going to be starting at negative pi thirds. I am going to be going 1, 2, 3, 4, 5, and I'm going to be over at 2 pi thirds. And so for this, I am going to end up let's see. So I just want to show you why you have to be careful when you're starting on the negative side of the x-axis and not completing your cycle on that same side. We started on the negative side, we ended up at the positive side. A lot of times people assume the y-axis is one of your nice 5 points, but it may not be. So I put this into Desmos here. So this is our equation. And I added a restriction, which is our period that we're plotting from negative pi thirds to 2 pi thirds. So you see here we have that. And let me just also add in our high. So our middle was -2. Our high is going to be 3 above that. So y equal 1. And our low is going to be 3 below our -2. So that's going to be y equal -5. Okay, so let me just make this bolder. Okay. So what you'll notice is, okay, here, this is at my negative pi thirds. Here, this is at my positive 2 pi thirds. And you'll notice here's my y-axis, and it's not one of my highs or lows or zeros. So my low is here at negative pi 12s. My 0 is here at pi 6, and so on. So I just want us to be careful when we're starting on the negative side of the x-axis and our cycle continues on to the positive side of the x-axis. We just need to be careful. So let's just kind of get a general look at this. Okay. Now, again, for this, let me just kind of highlight. We are shifting up 1. Okay, so let's pretend this is here at a height of 1. Let me just write that here. We are going to be going up 3. So our high is going to be 3 above, which is going to be at 4. And it's going to be 3 below, which is going to be at um, which is going to be, oh, actually, I put this into the equation here. It was a -2. I put a +1. I put the wrong one here. So let me just bring this back for a second. So this was a +1. Okay, so that we are shifting it so that our center is at a +1. I apologize. And that means I'm going to go, so my center is going to be at a +1. My high is going to be 3 above that, which is going to be up at 4, and 3 below my 1, which is going to be at a -2. Okay, but again, I had just shifted the whole graph down, but you'll notice that still in this situation, we have our zeros and our highs and lows still not on the y-axis. So we just want to be careful with that. Okay, so that my high is 3 above that, which is going to be up at 4, and 3 below, which is going to be down at -2. Let me just plot this, and then I will sort out where my y-axis is. So this is going to be sine always starts at 0, ends at 0, halfway in between 0. Because it's negative, I'm going to go down, and then I'm going to go up. And so this is going to be my graph. Now, in this situation, my my y-axis is not going to be one of these nice points. It's going to be somewhere here will be my y-axis, but again, it's not one of the nice points. So again, this was a height of 4, this was a height of 1, and down here, this was down at -2. A little more challenging one than what we've been dealing with. Letter B is a little challenging too. Our amplitude is 5. Our vertical shift is -2. Our period is, and this is where we want to be careful. In this case, we have the 2x inside our parenthesis instead of having the 2 outside like we did on letter A. But that 2 is still my b, so I'm still going to take 2 pi divided by 2, which is pi. Now, this is where it gets a little hard. When I take 2x plus pi force, which is inside my parentheses, set it equal to 0, I'm going to get 2x is equal to pi force. I'm going to divide by 2, and I get that x is equal to pi eighths. So I'm going to be starting at a negative pi eighths, So let me see, I'm going to be starting down 2. So let me just kind of figure out, let me shift it up a little bit. Okay, so I'm going to be starting at a -2. Okay. Now, in terms of my x-axis, I'm going to be starting at negative pi eighths. Where am I going to end? Okay, so I am going to be taking negative pi eighths. I'm going to be adding pi onto it, which is 8 pi eighths. So I'm going to end up at 7 pi eighths. So I'm going to have 1, 2, 3, 4, 5. And I am going to be ending at 7 pi eighths. And so in this situation, again, I'm starting on my negative side and I'm going to my positive side. And each mark here is not like an eighth, which would be nice. This is really pi distance, so I'm really going pi force each time. Okay. And so where I'm going to end up at is having my y-axis in between these two right here is what's going to be happening. So for most of our graphs, we are generally starting on the positive side of the x-axis and ending on the positive side. Or maybe we're starting on the negative and we remain on the negative. This one again is like this one where we're going across. So I just want you to be careful because again, these tick marks, none of these are actually going to be a y-axis, none of these. So I normally don't mark all of these values, but I'm going to just to emphasize where we're at. So again, I'm starting at negative pi eighths. I'm going pi away, which is really 8 pi eighths. And I end up at 7 pi eighths. Now, what's happening is every one of these tick marks, as I've got 4 sections here, basically, is going to be a fourth of pi. So if I was to take, and let me just kind of do this in red, then I'm going to erase it. If I was to take negative pi eighths plus pi force, because again, each of these would be 1 pi fourth, 1 pi fourth, 1 pi fourth. I'm splitting it into 4 pieces. So if I split pi into 4 pieces, pi into 4 pieces, I've got pi fourths. Now pi fourths is the same as 2 pi eighths. So this would really be pi eighths. And then I'm going to add another another pi force onto it. Whoops, that was pi eighths. I want to leave that here. So now I'm going to take pi eighths. I'm going to take pi eighths and add pi fourths, which is again is 2 pi eighths. So I'm going to be at 3 pi. My pen's not working right now. So this one is pi eighths. This one would be 3 pi eighths. And I think you can see this one's going to be 5 pi eighths. Okay. So what's going to happen is my x-axis is actually going to be halfway between these two is where it's going to be. That is not going to be one of my marks though. Okay, so I just want to emphasize that. Okay, so let's get back to actually graphing the graph. So on this, I'm going to graph the high, middle, lows. So I am going to be having my middles, okay, my zeros, my vertical shift is going to be at -2. I'm going to be going 5 below, which is at -7. I'm going to be going 5 above, which is at 3. So let me just get my highs and lows and my vertical shift. And then let me plot this. Now, again, this graph's a little harder than what we're going to be seeing on a test. So this is a cosine. A cosine starts high to high or low to low. It's positive, so it's going to be high to high. So I'm going to start up here. Oops, I'm drawing in triangles. Let me get, okay, a point. So at negative pi eighths, I'm going to be starting at my high. And at 7 pi eighths, I'm going to be ending at a high. Halfway in between, which is my 3 pi eighths, is going to be my low. And then halfway in between these, which is this pi eighths, not this y-axis, is my 0. And over here, 5 pi eighths, that's my 0. And then we're going to sketch this graph. And there you go. Again, a little harder than the ones we've been seeing. On number 6, in this situation, we have a graph that they want us to do a sine and a cosine for. Okay, so whenever I have to come up with an equation, I always focus on finding where the high is, finding where my low is. So my high's at -1, my low's at -5. Halfway in between there is -3. I can average that. And -1 plus -5 is -6, divided by 2 is -3, or visually I can see that. So what this tells me right away is that my K is going to be -3. So I'm going to have a -3 at the end of my equation. I also know that my amplitude, my A, now it might be positive or negative, but my A is going to be 2. Now, I'm going to decide where I want to start. So for a sine graph, if sine, you want to start at your 0. So I could start here or here or here. Oops, I was trying to make that a different color. Or here or over here. I can start at any of those. Okay. So if I started at this purple one, I would have a positive sign. If I started at this pink one, I would have a negative sign. If I start here at this one, positive sign. If I start here at this one, negative sign. Now, if I start here at this one here, this will have no shift at all. No, it will have a vertical shift, but no phase shift. So maybe I'll start it here. So what I'm going to do is, again, for my sine is that. That's my sine. And so when I'm looking for this particular one, for my phase shift, I'm actually going to have I'm going to have no phase shift for my sine, okay? Because I'm going to be starting at 0. Now I need to figure out my B. My B is my period. So if I'm looking at what I just colored in, I'm going from 0 to 4. So that means my period is equal to 4. That's not my B. My period is equal to 4. So remember, 2 pi over B is equal to period. So I'm going to get 2 pi is equal to 4B. So B is going to be 2 pi fourths or pi halves. So I have enough to write my sine. I'm just going to write my sine equation right here. I'll do it in red. Okay. So for my sine, I'm going to have y is equal to, I'm doing a positive, so +2 sine. I found that my B was a pi halves. I have no phase shift, so I'm going to put X. And then I have my -3. That's my sine equation because I chose to start right here. Now for a cosine, we want to do high to high or low to low. So I do not want to be doing any of those ones. Okay. Let me get my vertical shift back in. Okay, so I don't want to be doing any of those. I want to do highs or lows. So I could do this. I could do this. I could do this. I could do this. I could start at any of those points. So I think I'm going to start at this one right here. That's at -3. So that means my phase shift is going to be starting at -3. So that's going to shift things. So let me do my cosine graph in equation in orange. So this is going to be y equal. My amplitude is the same, and it is going to be positive because I'm choosing to start here at this one. If I started down here, that would have been a -1. Okay, so my sine is going to go, my cosine is going to go from here to here. The period is still the same. The period for the sine and the cosine will be exactly the same. You can see I went 1, 2, 3, 4 units. but I'm just starting in a different location. So this is going to be cosine. My b is still pi halves. I am starting at a -3, so I'm going to write x plus 3. And then I still have that vertical shift of being -3. And that's our equation. Okay, so on the next problem, so on number 7, this is one of the using modeling with a sinusoidal function. So we're looking at Chile and plotting their temperature. We know that on January 7th, the temperature is 29 degrees Celsius. And we know that the coolest day of the year is 14 degrees Celsius and occurs half of a year later. And the temperature over time varies sinusoidally. And we're using 365 days as the length of the year. Okay, so my high is going to be 29. The low is going to be 14. And if we average that, okay, so I'm taking 29 plus 14 and then dividing that by 2, I get 21.5. Now, this is going to be my vertical shift. This is my high and low. Now, in terms of what's happening here, my amplitude is the distance here to here. So A is going to be 7.5. That's going to be my amplitude. Okay, and we're going to be starting on January 7th. So we're going to be counting days 1, 2, 3, 4, 5, 6, 7, 8, all the way to 365. So it's not necessarily going by the calendar in the sense of like, if I'm in March, I'm actually not going to be saying March 1st. I'd be counting how many days in the year it's been so far. So the first mark I know is, the 7th day. Okay, so at this point I've got 7, and then I'm going to go 1, 2, 3, 4, 5. And we know that that's going to be our coldest day. Okay, so our coldest day, so that's going to be a high. This is going to be a high. This is going to be a low. This is going to be a 0 and a 0. Okay. Now I know that the 14 degrees is half of a year later. Okay, so 1 whole year later is going to be 7 plus 365. So that's going to put me at 372. So this is going to be at 372 days of the year. And this is going to be our graph. This is days, and this is degrees Celsius. Okay, and I would write a cosine graph for this. Positive cosine, amplitude 7.5 times cosine. Now I need to find our b. The b is 365 days. Okay, this is 365 days. So to find my b, I'm going to take 2 pi over b equals 365. So 2 pi equals 365b. So 2 pi over 365 is my b. So 2 pi divided by 365. That's going to be my b. We're starting at 7, so this is going to be x minus 7. And then we shifted it up 21.5. And that's our equation. Okay, on 8. So on 8, we want to get common, the bases to be the same. So both of them can be 5. 5 squared is 25, and then that's going to be raised to the 7x plus 22. 125 is 5 cubed. Now I have power to power here. So this power 2 is going to be multiplying with this. And so I'm going to have 5 to the 14x plus 44 is equal to 5 to the third. I set the exponents equal to each other. And so I get 4x is equal to negative 41. I get x is equal to negative 41 over 14. And leave your answer like that. On this next one, we want to get all of that as a single logarithm. So this is going to be log base 2 of x divided by x minus 3 equals 3. Then we're going to rewrite this in exponential form. We're going to take our base, which is 2, to our power, which is 3. So we're going to have 2 to the third is equal to x over x minus 3. So 8 is equal to x over x minus 3. And I'm going to get, when I multiply both sides by x minus 3, 8x minus 24 equals x. I am going to minus 8x. I get a negative 7x. So I get 24 over 7 is equal to x. And that is our answer, as long as it does not make either of these 0 or negative. It's definitely not going to make this. 7 goes into 24 more than 3 times, so this is not going to be negative. So that's a good answer. On 9, this is that sum and difference of 2 cubes. So the cube root of x cubed is x. The cube root of 1000 is 10. That's my binomial. Then I'm going to take this term x, I'm going to square it. Change my sign. This was a minus, so this is going to be a plus. Multiply the 10 and x together. And then square my negative 10. And that's our answer. On number 10, we are going to do all of our p over q's. My p is going to be everything that goes into 35. My q is 1. So I'm going to have plus or minus 1, plus or minus 5, plus or minus 7, plus or minus 35. Have no fractions because this is a 1. Okay, so let's just start doing our synthetic division. So I have 1, negative 6, negative 12, 30, and 35. So let's just say I start with 1. So I'm going to bring down my 1. 1 times 1 is 1. I add it to negative 6. I get a negative 5. Negative 5 times 1 is negative 5. I add to negative 12, and I get a negative 17. Negative 17 times 1 is negative 17. Add it to 30. I get a 13. 13 plus 35, I end up with 48. So that didn't work. Okay, let's say I try 5. So I'm going to bring down my 1. 1 times 5 is 5. I add, I get a negative 1. Negative 1 times 5 is negative 5. I add, I get a negative 17. Negative 17 times 5. So negative 17 times 5 is a negative 85. So plus my 30, that's going to give me a negative 55. And when I times that by 5, I get a negative 55 times 5. I get a negative 275 plus a 35 is going to be a negative 240. So that's not working. Let's see, 7, bring down my 1. 1 times 7, 7. I add it with -6, I get 1. 1 times 7, 7. I add it, I get a -5. -35, I add it, I get a -5. -35, I add it, I get a 0. Okay, so I've got 1, 0. So now I'm going to take this and I'm going to do another synthetic division. This was degree 4. Now this one's going to be degree 3. So I have 1, 1, -5, -5. Okay, I'm thinking I'm going to try a -1 or a 5. So I bring down my 1. 1 times -1 is -1. I add it to 1, 0. 0 times -1, 0. Add to -5, -5. -5 times -1 is 5. Add it to -5, 0. So I did end up getting another one. And then I'm left with a quadratic, which is x squared minus 5 equals 0. I'm going to add 5. I'm going to take the square root. I get plus or minus root 5. So I've got that. I've got a -1 and I have a 7. Those are my 4 answers.